One of our recent recovery projects for a sunken vessel in at Wollongong Harbour, those of you at Wollongong may remember at Belmore Basin, it requires our guys to go down and do an assessment of the vessel, consider its position on the bottom. We have to take into account environmental factors to ensure that environmental contaminants or any contaminants are contained so that we don't create a bigger problem for our client and introduce and create issues for the environment. So we are required to do a good safety environmental risk assessment before doing the actual work itself. But in this case, we utilised a large land-based crane. It was a 150-tonne land-based crane to lift the vessel up. So part of the process of recovering a vessel doesn't just require just putting some rigging underneath the vessel and just hauling it straight out of the water. You can imagine there's a lot of water that actually goes into the vessel which causes it to sink. So when you go to remove that vessel and bring it back up to the surface, that water has to go somewhere. You can't just lift the boat out of the water with it all full of water. It's too heavy. And it also runs a huge risk of actually breaking the vessel apart, because the vessels are not designed to have water on the inside, they're all designed to be on the outside. So when the vessels get up to the surface and they just break the surface, that's where we start the pump out stage. So we have to sit the vessel there just above the water line. We have to have the gunnels of the boat or the vessel just above the water line so we can start to pump the water out. If we don't have the gunnels above the waterline, we'll be pumping for a very long time trying to empty the ocean. So we have to get the gunnels above the waterline. We get our sea pumps in there and we start pumping out all that seawater. As that water starts to evacuate out of the hull, the boat actually starts to return to a positive buoyancy situation where it will start to actually float itself. So the crane actually starts to become redundant as you remove the water from the vessel and you get it back to a floating state. However, in most cases, you don't want to leave these boats in the water because there's obviously a reason that it went down. There could be a hole in the hull, there's some sort of structural damage to the hull, so it's going to be at risk of sinking again. So what we do once we get the water out of the hull, we then have just the dead weight of the vessel to manage and not all the water. So then it becomes a fairly safe and standard recovery with the crane, as long as the crane is within its safe working limits. That's also a challenge for us to determine before we order a crane or book a crane in, what type of weights are we dealing with here. We need to do some sort of assessment on the vessel. We need to know its length. We need to know its beam, how wide it is. What's the construction it's made out of? Timber hull? Is it a steel hull? You know, what is inside the vessel that we need to take into account to try and calculate its weight? These things may seem quite obvious that people should know, but it's quite surprising that when you go and do these projects, and we do quite a lot of them, there's huge variances in what people think the vessel might weigh and then what it actually ends up weighing.